The thing is, the best they my counselor. So I know my counselor's name is they want to right there.
Hey, listen, ladies. Okay, so look at me, please. Look at me. Okay, a couple of things regarding the test that's coming up on Wednesday. One, several people, a few people have kind of asked me, how do they know if they're prepared for the test, since it's not like the practice tests that you are perhaps accustomed to, where practice tests and real tests are copies with the numbers changed. A really good way to know if you are ready is to make sure that you get through all 60 of these fairly early, so that like on, say, Monday and Tuesday of next week, you have time to go back and do like 25 questions at random, since that's how many questions are on the test, and treat it like a true practice test. Like, don't look at notes, don't get help, just see if you can do 25 problems at random, and then score yourself. That's a good way to see if you're ready or not. With that in mind, my advice is, I don't ever write on my practice test if I can help it, like at all. Like sometimes you have to kind of write a little bit on a graph or something, but try to avoid writing on it so I can keep using it for practice. Like if it's written all over the place, the only thing it's good for is a very ineffective method of study. Let me demonstrate. See if you can relate to this method of study. You get out your practice test the night before the real test, and you read, you go, look at your work, and you kind of read it, and you got that one, you read the next one, you got that one. This is your study method. If that's your study method, here's what will happen during the test on Wednesday. You come into class, you sit down, I hand you the test, you look at it and you go, yep, I've seen one like that before. Nothing. Like, that's all you'll remember is that you read about it the night before. You won't remember how to do it. Like, you won't remember the concepts or anything, because reading isn't studying. Like, they did a pretty big study once, and they found students who would read over and over and over again material for a class, and they didn't make hardly any progress at all. Like, the way you make progress is you have to self-quiz. So the way I study is I get it all done, like I say, early, and I just redo it. I take it as a test, see how I'm doing. When it gets close to the test, I'm kind of running out of time to redo things. Then what I do is I have in my notebook my steps, like how I kind of worked out each problem. I take another piece of paper that's blank, and I cover up all my steps. And I did this all the time in college. And then I look at the problem. I don't uncover everything, just the problem. And then I mentally think, okay, what would be the first step? And I check to see if I'm right. I'm self-quizzing. Self-quizzing is how you really study. Don't just read things. You're wasting your time. So, questions? Awesome. So, to help with your preparation for the test on Wednesday, and I will do this pretty much as I can throughout the year prior to a test, I reserved today for a very thorough discussion of as many different practice test problems as you would like. Now, to be fair to those who have tried to get through the practice test already, if you haven't, you really shouldn't ask. Like, it's not fair you haven't put forth the effort. It's better to say those who have attempted, got stuck for some reason, they can ask about anything and then we'll talk about it. Second thing is this, look, as you are studying for the test, make sure that you stay completely focused on concepts. The real test is all different problems. So that means as you're working a problem, you have to know the reason why you do what you do. Sometimes the reason is simply a memorized fact. That's normal. Like, I give you certain memorized facts that explain that, yeah, we don't have time to delve into all the reasons, but just memorize it. But a lot of times there's a logical connection between things. Pay attention to that, then you know you're ready for the test. So, questions? So does anyone who's worked on practice test problems have one they want to talk about? So we're just going to kind of go from person to person today rather than make a list, just partly for variety, partly just because the heck of that. 4. There we go. Let me put this on a different screen just so it's easier to talk about. I'm going to demonstrate, if I'm taking a test and I read a problem, it's not going to be this one, but I may read a problem that involves horizontal asymptote, I may read a different problem that involves vertical asymptote. That's the key to studying the concepts, not the problems, is this one problem is meant to help you remember what do we mean by horizontal asymptote. It's meant to remind you what do we mean by vertical asymptote. You may need those concepts in completely different types of problems. But the one thing that has to happen is every one of you, when you read the word horizontal asymptote, you have to recall from memory what I'm about to write on the board. And if you're not recalling from memory what I'm writing on the board, you need to be making, yes, Mr. Maria, you need to be making flashcards so that you can remember. Don't do your flashcards just Tuesday night. That's not going to work. Do your flashcards like regularly so that every time you go through the file, you're like, oh, I never make a mistake. I know all this stuff. So here's what I remember. I'd say, okay, wait a minute. Horizontal asymptote, what does that mean? That means for this particular formula, for x, for this particular formula, I know that when x has a very large value, y will either be equal to 2 or at least really close. That's what we mean by horizontal asymptote. Questions there? Please. Huh? So, for some reason, the word horizontal asymptote makes people feel like there should be some big, complicated definition. And for our class, there isn't. It's just, hey, what's a function? A function's a list of x, y pairs. Oh, by the way, for this particular function, if you choose a very large value of x, the y value that the formula will compute is going to be pretty darn close to 2. So when they say horizontal asymptote at y equal 2, that's what it is. According to Maggie, comment? Please.
So it's just if it's a really, really big number on the left, then maybe 2?
Or it could be extremely negative, either way. So positive or negative infinity. So the next thought I had, so that's what's going to come to mind from your flashcards. Related to that would be this. It means the same thing. The limit as x approaches infinity for this formula that's got to equal 2. So all of this should just come right from memory. There should be no hesitation. It should just pour forth from your mind. Cool. But having kind of remembered that, you then would do a little bit of analysis. You'd say, okay, so wait a minute. This is how I find the y values. But if the x value is unbelievably large and getting unbelievably larger, what that means is that when I add these two together, I don't think I'm going to notice the b or the c. So really I'm doing this. I've got an x and I've got just this formula. But wait a minute, that formula can be written like this. So if I plug in a large number, I get 2. Well, the only way to plug in a large number and get 2 is if the a value is 2. Because large divided by same large is going to be equal to 1. So by just kind of thinking through the problem, I figured out that a is equal to 2. We need to discuss that further. You all right, Doctor? See a sense of frustration there. So. What's that? Justin.
What happened to the again?
The B. What I did is I said, okay, if I'm plugging in, say, x equal 2, I can't just throw in the B. Because I'd have 2 times A plus some number, I don't know what that is, but I can't just ignore it. But if x is, picture a number that is the number 1, and then picture a million zeros. Adding B is not going to make any difference. But very little difference. Point for Justin. Please.
How do we know that the limit is 13?
That's what horizontal asymptote means. Maggie, there you go. Okay, next thing that's got to come straight from memory is I read the statement, vertical asymptote when x is equal to -3. So my brain says, oh yeah, that's right. That means when I plug in x, value -3, into this formula, the y value is going to end up being, I don't know what the numerator is, but it's not 0. But I know the denominator is certainly 0. That needs to just pour forth from memory once again. If you're taking the test and you're struggling to remember the flashcard facts, what happens is your brain can't handle it. It can't think about this problem because it's so busy trying to remember things that by the time you remember them, it can't remember where you were in the problem. You just get stuck in no man's land. So once I see this, then I go, okay, wait a minute. So if I'm plugging in -3, so that's like, let's see, that'd be A multiplied by -3 plus B. That's supposed to come out to be some number. And then -3 added to C, that's supposed to come out to be 0. Hey, I got it. C's got to be 3. Please, Drew.
So -3 is just an example number?
Yeah, just an example.
It could be anything?
Wherever the horizontal, yeah, I would handle the problem exactly the same way. So the general principle is that whatever x coordinate that they identify the presence of a vertical asymptote, I know that for that specific x value, the y coordinate is going to end up becoming something over 0.
Okay.
Not 0 over 0, but it's something other than 0 divided by 0. Point for Drew. Here we go. Liza. Cool. Point for Olivia. All right. Anybody else? Sweet. Reminds me of a friend of mine. This show's kind of old, but did any of you ever see the show, what's it called? It's like Who Wants to Be a Millionaire, I think? Where they ask multiple choice questions and you get more money, right? So I had a friend whose little 4-year-old daughter was super just enamored with that show. She loved it. So she would go around the house just following her dad. Dad, got a question for you. And she'd go, oh wait, what is it? Dad, what's my favorite color? She's like, A, red. You just make up. All right. Anybody else have a question they'd like to discuss? Oh, we've been asked if you guys are okay with it to show the United today in this period. It's kind of depending on the questions. We'll see. If we don't have questions at 2 o'clock, the fully loaded version lasts 15 minutes. So there's the medium range here. All right. Other questions? Anybody else? We'll do it at the end if we have time. Please.
I asked you a question. I have a question.
On anything. I think we're done here. Unless you have a follow-up. Sure.
If we just go over the
Yep. Hey, quiet, please. Quiet. One other comment about the practice test. If you notice, a lot of problems that are exact copies of homework problems, that is by intent. One reason is I just can't find enough problems to give you practice on. 2 is I don't necessarily want the practice test to become 60 new, super challenging, can't figure out problems. They're just meant to remind you of the concepts we've learned. because the whole point is to just know the concepts. And then on the test, you get random problems. So, number one. Just put on a new screen here, makes it easier to talk about. Right. The instructions were to identify A and B, basically come up with what number A should be and what number B should be. That sounds awkward. Find the values for A and B so that the function f is a continuous function. So again, just reminding you of stuff you should have in your flashcard memory. I would immediately think, okay, continuous means I can't have any vertical asymptotes. New word for you today. The AP test changed something. We were just studying this on Monday. They threw in a new definition that they had not used for like 50 years. Instead of referring to a hole, they referred to what's known as a removable discontinuity. A hole is, yeah, well, welcome to the world. Hole is kind of a subset of removable, okay? So for now, just kind of think of them as the same. As we go along, I'll kind of illustrate a slight difference, but it's pretty similar. So removable discontinuity, and no jump. Good news is, as I look at this, I know there can't be a vertical asymptote because none of these have a denominator. I know there can't be a hole because they don't have a denominator. Removable discontinuity for now, we're just going to put that in the same category. So jump is the only thing I'm worried about. Then I remember that jumps can only occur at x coordinates when I stop using one formula and start using another. So I immediately draw a table. And I think, okay, if I were plugging in x values in numeric sequence, the last x that would use the top formula would be exactly 2. And then the very next x would use the second formula. So I just plug those in. So let's see, 2 plus, so plug this in here, so 2 plus 1 squared, that's going to be exactly 9. When I plug in the other value, I get 2 plus squared plus a. That's really close to 4 added to a. A must be 5 to prevent the jump. Follow-up question. Please do.
So if a function has a corner, is that not continuous?
Oh, great comment. Point for that. What you're mixing up is the fact that if a function is differentiable, that function must first be continuous. And then once we establish that the function is continuous, a continuous function could have a corner or vertical tangent, and they would cause the function to be not differentiable. But it's not related to continuity. No? Please.
So vertical asymptotes and holes only occur in rational functions.
Yes, there has to be a denominator. So. Anybody else? All you do at that point is just repeat the process at the next place where the last x would be 4 and the next x would be 4 plus. So I'll leave that for you guys.
Okay.
Perfect. Do you have any other follow-up questions here? I have a different question on the practice test. Please, please. You're okay. No worries. You asked the whole room to stay on this question for a second. Okay, they're stressing really heavily the idea that you've got to have a very good flashcard memory. Here's one that's got to be firmly embedded in your memory. We talked from the very beginning of the year that a function is just a list of xy pairs. Okay? When I read a statement that says the limit as x approaches a of this function is equal to L, I immediately remember, oh, that's right. Let's see, are they talking about one of the xy pairs of the function? Are they talking about 2 xy pairs? Or are they talking about 3 XY pairs? Just show me your vote. How many XY pairs are they referring to when they make this statement? So a lot of people have got to get a better flashcard than me on this one. When they say the limit as x approaches a is equal to L, they're talking about exactly 2 XY pairs. If you're doing this, give yourself 2 points. They're saying that for this function, when x has a value that is slightly less than a, the y coordinate's either equal to L or it's very, very close. When x is slightly more than a, same thing. They're talking about 2 XY pairs. Here's a true or false statement. Are they giving me information that would help me figure out the value of a? Is that a true statement or is that a false statement? True, false, vote. Does this tell me something about, like this is specifically talking about this XY pair and this XY pair. But does it also kind of imply something about this one? True, yes, it does imply something. False, it does not. So, as usual, the AP test is very good at fooling people. The answer is false. It doesn't imply anything. You know absolutely nothing about that.
Because you can have it where it's approaching on both sides from one value, but then the actual value is like this value.
Well said, Bethany. Point. Yeah, the limit doesn't say anything about that middle point at all. Nothing. The limit only refers to the left point and the right point. I see what you said. Please, Justin.
Would that be like a question that AP does think that it's asking if it has to do anything with the...
Oh, gotcha. Good question. 2 points for that. I don't think they'll ever ask something like, hey, does this have anything to do with it? What they do in a more clever fashion is they craft a problem where you have to know whether that's true or not. For example, they did it here. They give you the limit statement, which is telling you this information. If the x coordinate's a little less than a, the y is really close to L. So the limit statement is telling us the stuff I'm circling in blue, right? They expect you to know that that gives you absolutely no information about what's happening at x equal a. So when you come to this statement, it says, does f of a exist? And your answer has to be, I have no idea. Is the function continue? Oh wait, here's one for the whole room. To answer, so this is for sure false. So we have a follow-up question about that. Oh, please, Drew.
Wasn't there some kind of rule that if the A plus and A minus were the same, that A had to be the same as both of those?
Really good comment. Here's what you're mixing up, no worries. Okay, to find this value, I have to know the answer to this question. What is the value of the function f when the x-coordinate is precisely equal to a? That's what I'm finding out right here. What you're mixing up is this. To find this answer, I have to find the left-hand limit and the right-hand limit. If they are the same, then that's what this is. But this still has nothing to do with x equal a.
Okay, that makes sense.
Does that make sense?
Yeah.
Point. Please. Huh? So what typically gets mixed up is this. Let me put a new thing up. Okay. If I want to find out the y coordinate when x is equal to a, I have to go find the value of f of a. Like that's the only way I can do that. So this is my function. You okay with that? When they ask me for the limit as x approaches a, come on, bring. They are not asking me what happens when x is a. They're asking me to figure out 2 things. The limit from the left and the limit from the right. Now, if both of those are the same, now I know what the overall limit is. Still had nothing to do with x equal a. We just think it does because that says x approaching a. It has nothing to do with x equaling a. Does that make sense?
Yeah, so
Go ahead.
what he was talking about was when it asks what f of a is.
What Drew is saying is, if they ask for this limit,
Yeah.
what do you have to do? You have to find the left-hand limit, the right-hand limit, and compare them. And if they both end up being L, then you know that this limit is also equal to L.
Okay.
But that still had nothing to do with x equal A. Brenda, please.
Okay, so I think what so the limits, like the left and the right, when they go together, well, I mean, when they're the same, the overall limit is the same. But if, like, say, f of A, well, we don't know if it's continuous or not, but like, on number 1, the reason we can do that is because we know it's trying to make it continuous, right?
No, it's very good, Brenda. Continuing that idea, so when we talk about a limit statement, really get fixed in your mind, that's only talking about 2 xy pairs. Only 2. When you talk about this statement right here, that's only talking about 1 xy pair. When they start talking about is a function continuous or not, now we are talking about 3 xy pairs. Because to be continuous, you have this in your notes, the limit as x approaches A from the left must be exactly the same value as the y coordinate when x is equal to A, and that must be the same value as the limit as x approaches A from the right. So that's on your list of things you have to have memorized as well. So, please, Sam.
So when that says like the limit like as x approaches A, it's talking about like a little bit less than A and a little bit more than A.
Mm-hmm. Yeah, the limit is only talking about what happens in the vicinity of A, not at A. That's the key difference. It's the whole idea of a limit.
So can it like, because when I think of like as x approaches A, it's like I'm thinking about smaller numbers going bigger, but it can be like bigger numbers going smaller.
Right, it's both. That's why we have to do that. No, it's perfect, Sam. That's why we have to do this. This is basically your thought of, hey, I want the x value to be less than A, like more negative than A, but I want to get as like so visually you're thinking I want it to be like the x coordinates come like this, right? You want those x coordinates to get closer and closer and closer and closer to A, but never become A. Okay. That's why when we do a problem graphically, you get an example. Hold on a second. So what you're thinking, Sam, is right on. It's like right on target, like right here. So make that bigger. Right here it says find the limit as x approaches A. Well, here's an x coordinate of A. If I follow this graph like so, I am choosing x coordinates that are increasingly closer and closer to exactly x equal A. But I have to stop my choosing process right here. Like I have to pretend I'm getting closer and closer and closer, because if I go to exactly A, suddenly at A there isn't a point. That's the idea of limit. Other follow-up questions here. So back on the problem itself, is f continuous at x equal A? The answer is I don't know, because the problem did not say anything about what's happening when x is precisely equal to A. To answer whether the function is continuous or not, I have to know all 3. Is the function defined? I don't know. We still don't know anything about what's happening at x equal A. Is the value of the y coordinate when x equals A equal to L? I don't know. I don't know anything about x equal A. So. Please.
So the reason that the options that we're not sure about aren't true, is that because the question is asking which must be true?
Very good. Yeah, all of these could be if we happen to know something about the y coordinate when the x coordinate is equal to A. Please,
So for option C, to be defined, it has to be a point there?
Kind of a safe way to think of it is at x equal A, I have to know the y coordinate.
You have to know it.
Think of it this way, Eliza, it helps me remember. If I don't know the y coordinate here, what word do we use to state that? We say undefined. It's the opposite of defined. Yeah, does that make sense? Please, Brian.
Is kind of A and C basically the same?
That's very good. Point for that. A and C are exactly the same thing. Okay. There's no difference. They just test you to see if you know both wording. Perfect. Anyone else who worked on the practice test had a specific problem about method? 16. The limit as x approaches infinity. My first thought, if you want to make a flashcard, well, if you remember, you don't need a flashcard. If you're struggling to remember, you need a flashcard. My first thought is, oh yeah, when x approaches infinity, a really effective method of solving a limit is to compare two things that are being added. So I go find two things that are being added, right? Yeah, what the heck? We'll do this one first. So those two things add. As x gets bigger and bigger and bigger and bigger, only the 3, well no, the 3 is going to become very, 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 very insignificant. So this limit looks like this. So I use that logic on all of it. I end up with this. I kind of jumped there quickly, so if anyone wants me to talk through how I got to here, just ask. Please, Alexa.
I understand like how you did that, but I just boiled the whole thing and just got rid of the other.
Gotcha. So if you multiply this out and then compare once it's multiplied out, totally legal. I would advise you to do one thing though. Make sure that this method that I'm showing you makes sense, only because I can truly see them giving you a problem where when you glance at it, you go, oh yeah, I don't want to multiply that.
Yeah.
So if you can do it this way, it might save you. So, this problem either way is about the same difference. But anybody else? So now I think to myself, okay, limit means the x coordinate's getting really big. So let's see. The good thing to do is this. Write out all the factors separately. So I say this is 2 over 1. Okay, what I'm writing on the board right now, I will do this all year long. So now is the time to speak up if you're like, oh, it's not making sense to me. I don't understand how you did that. Because I'll keep doing this the whole year. Listing out the factors separately makes it easier to see what's happening. As x gets really, 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 really large, these two values are going to be the same large values.
There be the negative, just put the negative 2.
Oh,
Like,
great comment.
Yeah.
So how many noticed that? Show me the point for that. You're asking why?
Yeah, so I was wondering if you just did it like on accident, or if it was on the x direction and move it off.
Perfect. Yeah, multiplication, it doesn't matter the order. So really what I'm thinking, Olivia, is at least I catch myself now. Yeah, I caught myself. Moving on. All right. So here's what I'm thinking, Carrie. It's really like 2 multiplied by x multiplied by negative 1 multiplied by x.
Yeah.
Like everybody hear that? This is not negative x. It's not. We all say negative x because we're all just too lazy to say negative 1 multiplied by x. Understand? So multiplication, the order doesn't matter. So what I wanted to do was make these easy to understand. So now I just look at them and say, oh, these are easy because you're plugging in the same value for x. So this, when x gets bigger and bigger and bigger, is always going to be 1. So will this, the whole thing's going to get really close to negative 2. Follow-up question. Oh, please.
This is just kind of random, but does that mean like a little bit less than infinity and a little more than infinity?
It's not random at all. It's just that infinity is not a specific number, so you can't think of it that way. Like, it's really the idea that x just keeps growing and it never stops growing. So it's just what happens, so there's not really left and right.
It's kind of like how in algebra, you're trying to get closer and closer to 2. So x is just trying to get like closer and closer to infinity.
Yeah, and even worse than that, in my opinion, is that what the heck does that mean, closer to infinity? Like, it's like the best example I've heard is the dumb game. Somebody want to play a dumb game with me? I'll pay you a point. Here we go. So Sam, so you name a, okay, now, just name a large number, I don't care. 100.1. Who's winning as far as naming the largest number? Yeah, so would you like to try again? 100.111. Who's winning? Yeah. If I go second, who's going to win? You. Yeah, it never ends. Like you can never end, you can never name the largest number. Do you get it? So as x approaches infinity, it just means x keeps growing. Like it's not getting close to anything. It just keeps growing. Yeah. Does that help? Perfect. 3 points per Sam. Question? Nice. Hey, are we good here? I had something else I wanted to tell you that's slipping my mind. Oh, I got it, yeah. Okay, huge hint for the top. Whenever you find a limit as x approaches infinity, you have automatically found something else. And ends up, you know what I'm thinking? If you read my mind, I'll pay you. If you read my mind incorrectly, I'll say, no, you're not psychic, sorry. So, as soon as I find a limit as x approaches infinity, I must remember this fact. If you don't, you will miss 2 or more problems on the test, guaranteed. So, right? Score. So this function, whatever that thing is, we'll call it out. We'll say, so, f has horizontal asymptote at y equal -2. Gotta remember that. How many knew it before she said it? 2 points. Question? We have a different practice test. Brenda, please. 22. 22? Okay, everybody stare at the board. Everybody stare at it. I want to make a comment here. Everybody stare at the board. Look at the board. Okay, look at the board. I want to see you looking at the board. Look at the board. I want to see you looking at it. Come on. Okay, here's my comment. I've taught you that when you're solving a limit, one of the very first things you really want to look for is, can I factor and then divide common factors? Nod if that sounds good. Okay, good. I'm just disregarding you like doing this. Okay, good. I'm ignoring you, I'll be honest. With experience, you learn, however, that there are some cases where I don't even have to look to factor. And in this case, I first looked at it and I thought factor, I did. When I just kind of looked a little bit more, I thought, no need. X is approaching 0, I don't need to factor. Originally, I can read my mind this time. Why am I saying that? There we go. Why do I look at it and say, yeah, my first impulse is to factor. But one thing you're learning in this class is to not, this is such a valuable skill for any job you ever have. Like you're learning to just think as you go, not just reflexively react. Quick story, just a personal experience. My wife is an ICU nurse at American Fork. She's worked on that unit for 25 years. She's really, really good. She's worked there a long time. She's noticed that once in a while they'll hire a brand new nurse, and she honestly feels very bad about this, but they'll hire a nurse who doesn't know how to think. The nurse knows how to recall information, but she can't think. And it just doesn't work for a unit like ICU. She can't just have like everything memorized because things change and situations are different. You've got to think as you go. So this is, honestly, this class is very good for that. So who knows what I'm thinking? Show me. What am I thinking? Matt.
Since you're plugging in numbers really close to 0, anything that has an x is essentially going to be 0.
Really close to 0. So Max says, you know, I got 3 things being added here. X just gets so unbelievably close to 0 that multiplying by 6, these add together. Now they're not 0, they're something really, 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 really small, but we could play the dumb game again and try and name the smallest number, and you'll never win either. It's like whoever goes last wins. Adding 2, you don't even hardly notice you're adding any of this stuff. So really, why am I writing limit? I'm done. The numerator, as x gets really small, is going to get very close to 2. The denominator is going to get very close to -6. Please.
So this was one of the questions on a proof, and it was like, it was getting close to 0, the answer ended up being
Awesome question. 2 points. 2 points. Hey, look up. Everybody look. Everybody look. The key there is that the problem we're working on, the denominator was getting close to 0. If the denominator alone is getting close to 0, okay, first of all, if both the numerator and denominator are both getting close to 0, most likely you have forgotten to factor and divide common factors. And if you'll do that first, then the problem becomes easy. If just the bottom is getting close to 0, which is what you're remembering, then you've got to be cautious. You've got to find out how are we getting close to 0. The problem you're remembering is actually in the practice test to help you remember that concept. It was in the homework, it was in the quiz, and I put it on the practice test to again remind you of the concept. It's right here. Hold on. There it is. Number 6. Shoot. Wrong button. Number 6. Somebody is laughing. All right. So here we go. X is getting close to 1. So when we plug close to 1, we get this. And the situation is exactly what Carrie was remembering. Okay, with the limit, you can treat the numerator and denominator separately. So the top is simply getting close to 1. But the bottom's getting close to that thing. So you have to have memorized. Natural log of 1 is exactly 0. Natural log of slightly less than 1 is barely less than 0. Natural log of slightly more than 1, barely more than 0. And that's what's going to cause the situation Carrie's describing, because this looks like this, which means this is a very large value. Positive divided by negative is negative. But the other way is this. A positive number divided by a negative number.
How did you get the negative number on the bottom?
Oh, because I have memorized the natural log of 1, a number very close to 1, but slightly negative than 1 is this value. So you need to have that memorized. It comes from the fact if you look at the LN graph.
Oh, I see. Yeah.
That's the LN graph. Right here, when x is equal to 1, y is equal to 0. So if x is equal to slightly less than 1, y is just barely less than 0, like that. So this is approaching positive infinity. Since the left and right limits are not the same, the overall limit is non-existent. Carrie, is that what you're thinking? Perfect. Please, Eliza.
So there's one like that on the test, but if you kind of set this off,
no, it could be anything. In fact, my advice would be this. When you're working a limit problem, if you follow this kind of sequence of logic, you'll be fine. So I think, first of all, is x approaching infinity? if x is approaching infinity, Eliza, I go try to do those comparisons. Now, a few comparisons that you also have to have memorized are these. This was in your notes. Exponential functions grow the very fastest. So that type of function is going to grow much faster than other types of functions. Power functions are second fastest growing. And then ln's grow, but just not rapidly. These are only true as x approaches infinity. So if x is approaching infinity, I remember this information so I can compare adding terms. Next thing, if x is not approaching infinity, I look to factor and divide. Last thing, I just remember, what does limit mean? Limit simply means I'm taking some x value and I'm trying to see what happens to the value of the formula they give me. That's all I'm doing. So in this case, I had to use, yes, my knowledge of ln, but in another problem, you might not have to use something else. Who else? Follow up question.
Okay.
So, anyone else? Please, Drew.
Can you do 21
Huh?
practice?
Are we good here? Oh, wait a minute. Please, for you. Please, come.
Was usually an S power giver or an S?
So Claire is asking this question. Really good question, Claire. As x approaches infinity, that's not what I want. Let the whole room vote, see if we can get a bonus point. As x approaches infinity, Claire wants to know, does x to the e, as I said, does x to the e power go faster, or would e to the x power go faster, right? Okay, so this is option 1, this is option 2, show me your vote, okay? Which one goes faster? So I'll give a hint, if you want to change your vote, feel free. Need to have memorized that e is just 2.7. So this is just the function x to the 2.7. So if you're doing this, give yourself 2 points. This is still just a power function, just an exponential. Claire, please make it look like something exotic. It's not really. It's just a power function. There you go. 21. Great. I hear voices. Yeah. Hold on, throw it over there. That one?
Yeah, I should have actually.
No worries.
Okay, real good.
You good? Yeah, don't hesitate to ask. Yep. 21. So, this is a really good example of what I just mentioned. I said a minute ago that if you are trying to find a limit and you end up with 0 divided by 0, it's very likely that you simply forgot to factor. So watch. I can think, okay, what does limit mean? What I was saying to Eliza a second ago. It means I have an x value. I'm plugging that x value into this formula. Just call that f. And I'm trying to plug in a little less than 0 and a little more. I'm not plugging in exactly 0. If I plug in exactly 0, I get undefined. Guaranteed. So I'm not worried about that. But I try to just think through it, kind of like we did with Max a second ago. And I say, well, this is going to get really close to 0, so will this. So the whole numerator is really close to 0. So is the denominator. If I'm trying to find a limit and I end up with close to 0 divided by close to 0, an alarm goes off in my head that says, oh, you forgot to factor. So questions? Doing okay? Now I'm going to write it out as individual factors. So this is going to be, let's see, 3 over 2, x squared divided by x squared, x squared minus 4 divided by 2 plus 3x. These all multiply. Again, if I plug in exactly 0, this would cause the entire expression to be undefined. But if I plug in numbers that are very close to 0, this will equal 1. That's nice. This will just equal 3 over 2. Here I can make comparisons easily now. If this is close to 0, this will be close to negative. This is really going to be close to negative 4. That's it. So I go 3 over 2. Negative 4 over 2. That's going to be negative 12 over 4. Okay, the whole thing's getting close to negative 3. Follow-up questions? Please ask.
So the last problem we went over like that, you said that it wasn't, we didn't need the factor.
Gotcha. No, great question. And the only reason why was that I think you can see, like, I think you'll see it. Notice here that both terms that I'm trying to compare, they both are multiplied by x. So this gets close to 0, so does this. So when I add them, I'm just getting close to 0. I can't really tell what's happening.
Right.
The other problem had a distinct difference. I can find it. Come on. Must be this way. Sorry, come on. That one. Here, there are 3 terms being added, but one of them has no x. So these two will get very close to 0. When I add them, still close to 0. But then when I add to 2, close to 2. That's why I didn't do that. Does that help? Good. Point. What? Different things in different classes because different questions come up. It's really important that you be comfortable with the phrase twice differentiable. Wave at me if you're comfortable with the phrase. Have I talked about that? Okay, good. So, nice, good to see you too. They're talking about this being the function f. And they're simply stating that if you wanted to find the function f prime, you can. And there won't be any missing points on f prime. Like f, the tangent slope of f can be found everywhere. Twice different, that would mean once different. Twice means I can do the same thing for f prime to find a list that would basically quantify f double primes.
So if it only said differentiable, it said twice, so you wouldn't for sure know what f double is.
Right, and actually what that would do is it would allow some really, really smart person to say, I can't solve this problem. Because you didn't tell me that f double prime even exists. So how can I possibly answer the question? So they say, oh, we'll avoid that little controversy. We'll make sure we tell you that the function is twice differentiable. Now we're saying so.
Can you just say again what twice differentiable means?
So the word differentiable means I have a function f, and if I go to every single point on f, if it is possible to find the value of the tangent slope at every single point, we then say that f itself is differentiable everywhere. It simply means that I can find the tangent slope of f at any point. Does that make sense?
Yeah.
That would make f once differentiable. You gotta think of it this way, Sam. Once you find the tangent slope at every point, you have found all the values that comprise f prime. Fair? If I plot those values, I get a different graph. If I then look at every one of those points, and find a tangent slope, I have now created what I would call f double prime. That means f itself was twice differentiable. No?
Yeah.
Cool. There we go. So this is f. I used Danica's chart. I say right there, f of 1 is definitely equal to 0. I can just look at the slope right here. If I were to draw a tangent slope, it would look like that. That tangent slope's value would be a positive number. Therefore, f prime, when x is equal to 1, which is, I read this and say to myself, this means, this is what I'm thinking, it means the tangent slope of the function f, when x equals 1, that tangent slope value is some positive number. So this is the tangent slope of f at x equal 1. Okay with that? To find f double prime, I can't see it, so I use the chart. Since f has a concave down shape, f double prime will have some negative value. So now I know the order is f prime is greatest, then f itself, then f double prime. Questions? Please.
Can you explain the f prime again?
So, yeah, I want eyes on me again, like everybody look at me. Okay, like, there's a bunch of things to memorize, and you need all of it to do well on the test, but there are certain things that show up a lot more frequently than others. One of those is this symbol. Okay? So you have to look at that symbol and just, as quick as you can say 2 times 3 is 6, you have to look at that symbol and say, hey, that symbol has 2 meanings. Here's how I remember them. One way my brain's thinking, okay, on the graph of f prime, at an x value of 1, there's some y coordinate, say 7, I don't know. That's one of the meanings I have that memorized. The other meaning is this, though. So f prime of 1 equals 7. Remember, the 7 is just a made-up number. I don't know what it is. So my brain does this. It says, oh, the tangent slope on the graph of f when x is equal to 1, that tangent slope's value is 7. That's the second meaning. So I used this meaning to look at the graph of f, visualize a line that is tangent at 1, and I said, I don't know what that slope is, but it certainly is some positive number. Does that make sense? No. It will show the cool. All right. Sorry. Oh, cool. Thank you, though.